Good morning, General Chemistry. How are you today? I hope everybody's doing wonderful. I hope you're enjoying the videos so far. We're going to start to get a little deeper in our reactions. I hope you at least watched the balancing reaction video before this one. And then now we're going to take what we've learned and we're going to apply it and start doing some calculations. Now, probably the single most important skill in chemistry moving on is to use your chemical reaction or your chemical equation like this one and use it in calculations as we move on. And so I'm so excited to do this video. Let's take this first example and do it kind of slow and start to learn where all of our numbers go. And then we'll pick up the pace and do a couple more. Now I've posted this Word document on Blackboard so you can work your way through these equations with me. So before you start this video, you may want to grab these problems and then you can take a look at them with me or try them ahead of time if you've already seen this. You're also going to want your common anions sheet. For the next couple of videos, you're going to need your periodic table, that common anion sheet, and we may need a unit conversion. So we're actually going to need a few things. And then as we work our way into some later videos, we're going to need a solubility table and an activity series. Now I went ahead and posted all of those as a PDF on Blackboard just in case you didn't get them in class. So I know we've handed out some of those, but just in case. So go ahead and check Blackboard before you start this video if you feel like it. All right, I'm so excited. Let's use our mole ratio. That deserves a sparkle pen. Anytime you can use a mole ratio, sparkle pen. All right, one of the most common questions in chemistry is, okay, let's take this reaction. You either know how much you have to start with. So in this case, we're given 10 grams of our methane and unlimited oxygen. So I'm just going to write it right above there. We're given 10 grams of our methane and we're given an excess of oxygen. So it's extremely common. You either know how much you're starting with because you're the one measuring it out, or you have a goal in mind of how much stuff you want to make. So this is probably one of the most common questions in chemistry. So this whole video is going to be how to calculate this. All right, so we're going to start with 10 grams of methane, and then we're asked how much carbon dioxide and water can we make. So that's these. So we're going to do some math and we're going to figure that out. Now, the first thing you have to remember from now on is that we have trust issues. All right, you absolutely cannot trust me anymore. I'm going to start to mess with you. There's a couple ways to mess with you in Gen Chem, and that is word funny and use names. So you can see I'm already starting. Something like methane, I will give you the formula for. We haven't learned how to name that, but oxygen, we have that. We have it on our periodic table, and we also marked our diatomics. So let's take a second, grab your periodic table. Let's just refresh what are our diatomics. And I'm going to grab my periodic table here. And they make a little, almost like a 7 on the periodic table. Let's list them out again. Anytime we have hydrogen, that's diatomic, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So anytime you see those names, those are your diatomics. Now that's one way I'm going to trick you. I'm just going to use the name. And then look at these. Carbon dioxide, we know how to name that. And just for funsies, I called it water, but I'll also put in dihydrogen monoxide. So that's one way to trick you. And then the next is to have us calculate with these equations. And I'm so excited because here's the biggest trick of all. Our last video, we learned that we are not ready to calculate with this yet. What is the one thing we have to do first, always? Grab your yoga pants and light a candle because you need to find your balance. Every time. You have trust issues. So I like to wear yoga pants while I do these problems. That reminds me to find my balance. Light a candle, find your Zen space. We have to find our balance first. So before we even tackle what this 10 grams means, or how to calculate carbon dioxide or water, we've got to balance our equation. Now this one we've actually balanced before. That was in one of our homework sets, and it was actually in one of our videos. So let's take a second to rewrite that equation, and let's balance it. We can't do any math with it until we balance it. So let's take a minute here. We've got CH4, 1 carbon, 4 hydrogens, O2, CO2, and H2O. Okay, so right off the bat, if we list out here, we've got 1 carbon, 4 hydrogens, and 2 oxygens. We've got 1 carbon. Now, I won't do this for every example, just this first one. 2 hydrogens and 3 oxygens. So we could tell right away this is not balanced, so we can't do any math with it. It is not an equal equation yet. We need these things to equal. So we can leave the carbons the same, 1 and 1. All right, let's fix the hydrogens though. We need to go up to 4 hydrogens. So how do we do that? I'm going to add a 2 here. And now that jacks with our oxygen. Oh, now we go up to 4 oxygens. So we're good on carbon, we're good on hydrogen. Now we need to fix our oxygens. Well, we need to go back over here and get to 4 oxygens. So how do we do that? We're going to add a 2 there. Awesome, we found our balance. That is a sparkle pen. You have to do that before you do any math with your equation. Why? Because this is our mole ratio. We will need this in our math. This tells us that we will use 1 mole of methane for every 2 moles of oxygen. We will make 1 mole carbon dioxide and 2 moles of water. That is our unit conversion for this entire equation. This mole ratio will be in the middle of all of our problems. It is one fancy unit conversion. It's just specific to this equation. All right, so let's go ahead and add in our balance numbers up here. I'm going to keep the question marked on there, but I'm going to add in a 2 here, and I'm going to add in a 2 there. And then screenshot if you need to, because I'm going to erase down here so we can start our math. Okay, why do we care about our balanced equation? Our mole ratio is how we literally unit convert between everything in our equation. Remember, we wrote that in our little last definition of chemical equations. They literally are equations. So we are saying that these things are equal. So I like to start with the one number I'm given. Just like our other mole problems, we're given 10 grams of methane. Now, all this is a fancy unit conversion. We are going to convert from methane. Let's do carbon dioxide first. We're going to convert from methane to carbon dioxide, and we're going to use our equation to do it. So how do we relate, though? Well, let's put the mole in mole ratio. What we have to do is convert to moles. You cannot use the mole ratio. You can't use your balanced reaction unless you're in moles. We can't go gram to gram. We have to go moles. All right, so we've got 1 mole for every crap. What number do we put in down here? Well, we're going to put in what we learned in some previous videos. We need to put in that molecular formula. So that's going to be CH4, so 12.011 plus 4 times 1.00. What is it? 79. It is okay to be off in our rounding just a little bit here. I'm not going to round until the very end, and I may cheat along the way in some of our later examples, but this is my molecular weight for this one. All right, this is awesome. This means we get to cancel our grams of methane. I'm going to put my formulas in there so I can keep track of what I'm trying to calculate. So grams of methane, and now I'm going to have moles of methane. Now we get to solve the problem. What are we looking to convert to? We're going to convert to carbon dioxide. That's what we're trying to do right there. So I am going to use this as a, oh, don't put the 1 in yet. I'm going to use this as a unit conversion. I'm going to get rid of methane and convert to carbon dioxide. All right, now in our balanced reaction, what are our moles there? Well, we didn't write it in, but it's understood that it's 1 and 1. And now we just canceled moles of methane, and we've got moles of carbon dioxide. So now how do we convert that back to grams? We've already done this before, reunion tour. Let's get rid of moles of carbon dioxide. Let's convert to grams of carbon dioxide. And how do we do that? What number do we need there? We need the molecular weight of carbon dioxide. So that's my 12.011 and 2 oxygens. So oxygen is 15.9994. I get 44.0098. Again, we could be slightly off for rounding, but just wait for it. We're going to fix this with sig figs at the very end. All right, plug this in. Hit pause if you need to. Grab your calculator. Let's plug this into our calculator. I'm going to do the same thing. I've got 10 divided by my 16. All right, times 1 and 1 times 44. And let's see, I get 27.433084441. Again, we could be slightly off there, but watch this. We're about to fix it like we've done all semester with sig figs. How many significant figures are we going to use? We were given 10 grams of methane with 3 sig figs. So we're going to leave our answer in sig figs. So what is this going to come out to? It's going to come out to, 27. I'm not writing for some reason. 27. Okay, 27. Something is going wrong, y'all, and my pen is not writing. And it just was writing. Everything has frozen.